So we continue our lecture with the production of alkyl halide. When the alcohol react with PBr3, so as you can see here, the arrow is from nucleophile to electrophile, because here we have two lone pair here. The species that has more lone pair we categorize as nucleophile, because when more lone pair means that more electron. More electron, the species will become more negative. So that species we categorize as nucleophile. Then this O will react with P here to form the bond here, OH. And we assume that we know that this 2 electron is given to the P. So that's why here you put positive, because this O is because O lost its electron, so it become positive here. So it will be here PBr2, and bond here break, so it will form Br minus. The alcohol group attacks on the phosphorus atom and displaces a bromide ion to form protonated alkyl dibromophosphide. And the bromide ion attacks the protonated alkyl dibromophosphide. Here is nucleophile. Always remember, nucleophile attack the electrophile here, because this species we categorize as electrophile, because here is positive charge. To perform dibromophosphide and HOPBr2 leaves the group, the alkyl halide is produced from the reaction. Example, alcohol is reflux with phosphorus trichloride PCl3 to produce chloroalkane. Here ethanol react with phosphorus trihalide reflux at high temperature to produce chloroethane and phosphonic acid. However, the reaction of alcohol with phosphorus pentachloride occurs at room temperature. So it also produces alkyl halide. Reaction of alcohol with thionyl chloride occurs under reflux to produce chloroalkane. So we have a few tests to differentiate between the classes of alcohol. So for Lucas test is used to differentiate between the primary, secondary and tertiary alcohol. For type of alcohol, we have primary, secondary and tertiary. So observation with the Lucas reagent, for primary alcohol, no cloudiness. For secondary alcohol, the solution turns cloudy within 5 minutes. For tertiary, the solution turns cloudy immediately. For iodoform test, ethanol or any secondary alcohols that have the following structure unit will give a positive iodoform test. If ethanol is heated with iodine in aqueous sodium hydroxide, pale yellow crystal of iodoform appeared. The result show that the ethanol here is oxidized to triiodomethane with iodine. Oxidation. So basically, we can also do the oxidation test of primary and secondary alcohol with potassium dichromate. Potassium dichromate is an oxidizing agent. The bright orange dichromate ion is reduced to green chromium 3 ion. Okay, if the orange color change, primary alcohol, or blue-green, no, this one is secondary, and or blue-green primary alcohol, and oxidation reaction has occurred. If the color remain orange here, no reaction has occurred. So this sample or this chemical is categorized as tertiary alcohol, because tertiary alcohol is non-reactive towards oxidation reaction. For ethers are organic derivative of water but have two organic groups bonded to the same oxygen atom. So here you have ether, oxygen in between this carbon and this carbon. So we call as a diethyl ether. Diethyl because here is 1, 2. 2 carbon, ethyl. When these two groups observe at this structure, we need to put diethyl ether. So diethyl ether is the common name for this solvent or used as anesthetic and solvent. And anisole. Anisole is a pleasant smelling aromatic ether used in perfumery. Okay, when the benzene ring combined with OCH3, we do not name benzene. So when benzene combined with OCH3, it has another name, or we call as anisole. When the ether is in the formation of a cyclic compound, for example here you have 1, 2, 3, 4 carbon in the cyclic compound. So oxygen in between this carbon and this carbon. So we will name as tetrahydrofuran or THF, that used as a solvent. For naming ethers, simple ethers with no other functional groups are named by identifying the two organic substituents and adding the word ether. Okay, you have here is isopropyl. Why? Because here is 1 carbon, 2 carbon, 3 carbon. So this formation is just like V structure. We call as iso. Why is propyl? Because here is 3 carbon. So you put isopropyl. And here is methyl. Put methyl and ether. You need to arrange based on alphabetical order. Start with I followed by M. And you need to put ether name at the end of the naming. Okay, here you have two carbon in the structure, 1, 2, representing ethyl. Here is when the benzene ring become a substituent, the name is not actually benzene. It will change to phenyl. So it will be ethyl phenyl ether. If other functional groups are present, the ether part is considered an alkoxy substituent. Okay. So here you have benzene ring and 2 ether group. So you have 2 ether group on the benzene. So how to name the structure? So you start from here, 1, 2, 3, 4. So 1, 4 dimethoxybenzene. So benzene will be the parent chain and this ether will be the substituent. 1 and 4 is the location of the ether group on the benzene ring. So why you need to put di? Because this ether, it has 2 group on the benzene ring. So you need to put di. In between, numbering and alphabet, you need to put dash. In between number and number, you need to put comma. Okay, for this structure, you have ether and it attached to this structure 1, 2, 3, 4, 4 carbon. So 4 carbon is third butyl actually, but when it combine with oxygen, it will become third butoxy. Why is third? Because third, this carbon here is tertiary carbon. Third is stand for tertiary. Why 4? Because here, we start from here 1, 2, 3, 4. 4 is the location of this substituent. So always remember double bond will be lowest number, will be highest priority. So here is number 1. So that's why you put here 1 cyclohexene. Okay, formation of ether. If excess ethanol is warmed to 150 degrees C, the water molecule is removed and the main organic product is ethoxy ethane, or we call as diethyl ether. The reaction is known as Williamson continuous ether synthesis. Okay, you have here excess ethanol. You heat and this compound, which is H2O, will eliminate from the reaction, and finally you will produce ethoxy ethane, or we call as diethyl ether. Diethyl ether is the common name. Here is the IUPAC name. Okay, for phenol. Okay, phenol and aromatic alcohol is an organic compound that contains a hydroxyl group bonded directly to a carbon atom of the benzene ring are called phenol. Okay, structure of phenol, when the benzene ring combine with hydroxyl group, it will become phenol. Okay, types of phenol. Okay, here we call as 1, 2, 2 nitrophenol. And here is 1, 2, 3, 4, 4 methyl phenol. Okay, phenylmethanol. Okay, for this structure, we make this red one as a parent chain. When benzene become a substituent, the name will change to phenyl. So phenylmethanol. Hydroxy group become a part of the side chain. Okay. Benzene 1,3-diol. Okay, here is 1, 2, 3. 1, 2. 1, 3 is the location of hydroxyl group on the benzene ring. Why you need to put di? Because you observe 2 hydroxyl group on the structure. You need to put diol, benzene 1,3-diol. Okay, reaction of phenol involve reaction with aqueous sodium hydroxide. Phenol is likely soluble in water, but dissolved in aqueous sodium hydroxide at room temperature to form the salt of sodium phenoxide and water. Aqueous sodium hydroxide at room temperature to produce sodium phenoxide. Phenox come from naming phenyl. When phenyl combined with oxide ion, it will be phenoxide plus H2O. Phenol transfer a proton to hydroxide ion to form water. And phenol reacts with acyl chloride to form ester. Phenol does not form ester by direct reaction with carboxylic acid. Esterification is carried out by the reaction of phenol with acyl chloride or acid chloride. Okay, phenol cannot react with carboxylic acid at room temperature to produce the product. However, it need to react first with ethanol ethanoyl chloride, or we call is acid chloride, acid halide, we call as acid halide. Here is 1,2 ethanoyl chloride at room temperature to produce ester. Bromination of phenol. If bromine water is added to aqueous solution of phenol at room temperature, a reddish brown color of bromine become colorless and white precipitation of 2,4,6-tribromophenol is formed. No catalyst is needed for this reaction. This reaction is called bromination of phenol. Okay, this phenol react with 3 mole of Br2 at room temperature to produce this compound with white precipitate. We call as 2,4,6-tribromophenol. Okay, monobromophenol are obtained if the bromine is dissolved in a non-polar solvent such as tetrachloromethane. The hydroxyl group is a powerful activating group. It is an autopara director. Okay. This hydroxyl group, or we call as OH, as an autopara director. Why? What is autopara director? Autopara director is when this one react with Br2 in CCl4. So this OH will direct the Br to the location number 2, which is here. Location number 2 is Br. Location number 1, 2, 3, 4 is para. So at location number 2 is auto. At location number 4 is para. So here you put 2 bromophenol and 4 bromopara. So we can conclude that this OH will direct bromine to the location ortho, which is 2, and to the location para, which is 4. Nitration of phenol. Nitric acid react with phenol at room temperature to give a mixture of 2 and 4 nitrophenol. The OH group will direct nitro group to autopara carbon. Okay, it will locate the nitro group at location carbon number 2 and location carbon number 4. So here is 2 nitrophenol and 4 nitrophenol. Location 4 again is para. Location 2 is ortho. However, under vigorous condition, the nitration of phenol produce 2,4,6-nitrophenol. Means that you need to use concentrated nitric acid. So you will get this compound. Application of alcohol. So it can be applied to produce perfume, to produce wine, and for alcohol swab, and for solvent, for example, ethanol. Thank you for today.